Sunlight is all around us, but we cannot see its rays everywhere. We can see the sun rays clearly when sunlight enters a dusty room. Do you know why this happens in a dusty room? This happens due to the scattering of light by the dust particles present in the dusty room. Small solid particles, here dust particles, suspend in a fluid, here air, are known as colloidal particles. The phenomenon of scattering of light by the colloidal particles is known as the Tyndall effect. The same effect can be observed when sunlight passes through the trees of a dense forest. Here, tiny water droplets in the mist scatter the light. Let us do an activity to observe the Tyndall effect. For this, place a strong source S of white light at the focus of a converging lens L1. This lens provides a parallel beam of light. Allow the light beam to pass through a transparent glass tank T containing clear water. Next, allow the beam of light to pass through a circular hole C made in a cardboard and obtain a sharp image of the circular hole on a screen NN using a second converging lens L2. As you can see, the path of the beam of light passing through the clear water, that is, true solution, is not visible. Next, dissolve about 200 grams of sodium thiosulfate or hypo in clean water in the tank. Add about 1 to 2 milliliters of concentrated sulfuric acid to the water. What do you observe? The path of the light becomes visible through this colloidal solution. In about 2 to 3 minutes, you will find fine microscopic sulfur particles precipitating. As the sulfur particles begin to form, you can observe blue light from the 3 sides of the glass tank. When viewed from the 4th side of the glass tank, facing the circular hole at first, an orange-red color and then a bright crimson-red color are observed on the screen. This happens due to the scattering of light by minute colloidal sulfur particles, that is, the Tyndall effect. The Tyndall effect can also be observed in the atmosphere and can explain some wonderful phenomena of nature, such as the white color of the clouds, the blue color of the sky, and the reddening of the sun at sunrise and sunset. The Earth's atmosphere is a mixture of minute particles. These particles include smoke, tiny water droplets, suspended particles of dust, and air molecules. When sunlight strikes these particles, it gets scattered by the particles, and the scattered light reaches us. The particles scatter a particular color of the scattered light, and the color of the light that gets scattered is the color of the light we see. Let us now understand how it makes the clouds appear white. The clouds consist of large water and ice particles. These large particles scatter all the 7 constituent colors of white light vibgyor equally. Thus, the light we see is the combination of all colors, that is, white light. This gives a white appearance to the clouds. Let us now come to the blue color of the sky. The molecules of air and other fine particles in the atmosphere are of very small size. These are more effective in scattering light of shorter wavelengths, that is, blue light. Thus, when sunlight passes through the atmosphere, the fine particles in the air scatter the blue color of shorter wavelengths more strongly than the red color of longer wavelengths. The scattered blue light enters our eyes, due to which we see the sky as blue. Let us now try to understand how scattering of light makes the sun appear red at sunrise or sunset. At the time of sunrise or sunset, the sun is near the horizon. The light from the sun near the horizon passes through a large distance in the Earth's atmosphere before reaching our eyes. While traveling through this large distance, the blue light scatters away in all directions before reaching our eyes. Thus, at the time of sunrise or sunset, the light that reaches our eyes is of longer wavelengths, that is, red, and the sun appears reddish. It will be interesting to know that if the Earth had no atmosphere, there would not have been any scattering. Then the sky would have looked dark. Let's recap. The path of light becomes clearly visible due to the scattering of light by the colloidal particles present in the path. The phenomenon of scattering of light by the colloidal particles is known as the Tyndall effect. The Tyndall effect can explain some wonderful phenomena of nature, such as white color of the clouds, blue color of the sky, reddening of the sun at sunrise and sunset. When sunlight strikes the minute particles present in the atmosphere, it gets scattered by the particles. The particles scatter a particular color of the sunlight that we see. The color of the scattered light also depends on the size of the particles. Smaller particles scatter lights of smaller wavelengths, that is, blue light, whereas larger particles scatter lights of all the colors equally.